So now moving on to the second video of this section, and this is the last video that we're going to go over before your next test. So what this video is going to focus on is our word problems, and you will know how to not only translate word problems into proportions, but you're also going to have to be able to solve them as well. All right. These ones I think can be a little bit easier to translate than some of the other equations and inequalities that we had, because we simply are just going to create a table, and this table will allow for us to then write and come up with our proportion. So I do think that these word problems are actually a lot easier than some of the ones that we have been doing throughout the year. All right, so we're just going to go ahead. I think there's 3 problems that we're going to do in this video, and that will be it. All right, so for this, the directions in the question will say just to write a proportion, but we're going to solve them as well because we want to practice how to solve. So the first example is a chef increases the amount of ingredients, and here we are given the ingredients to this black bean soup over off to the side. And it says the chef increases the amount of ingredients in a recipe to make a proportional recipe. So because this is what we would do, how much ingredients we would use for this amount, maybe we're making like 2 cups of it. If we want to make for more people, we need to make sure the recipe stays proportional so it tastes the same. So if you're serving it for just 1 person, you would shorten and make the recipe a little bit smaller. And if you're serving it for 10, you'd have to increase what you're using for each one. But we would need it to be proportional because we don't want the recipe for 1 person to taste different than when we make it for 10 people. All right. It tells us that the new recipe is going to be 6 cups of black beans. Write a proportion, and we're also going to solve that gives a number of X of tomatoes in a new recipe. So when we're doing this, we need to identify the 2 things that we're talking about when we're trying to figure out a proportion, all right? Because we're comparing several quantities, and when we're doing a proportion or ratios, we're comparing 2 different things. So we want to identify what is it that we're trying to talk about or solve. So we know that we're given information about black beans, and we're asked to write a proportion dealing with tomatoes. So that is what we're looking to use. Those are our 2 things that we're comparing here. And the way that I'm going to have you do this is I'm going to have you create a table. It'll look like this. All right, and what we're going to do is we have black beans that we're looking at, and we have tomatoes. And we have an old recipe, or the original recipe, and we have a new recipe. So we're looking to see what can we fill in. Do we know how many black beans we have in our old recipe? Yeah, it says 1.5 cups. So we have 1.5 cups here. And then in our new recipe, we know we're now going to have 6 cups of black beans. When I look at the tomatoes, I know my old recipe or my original recipe, I only had 1 tomato for 1.5 cups. And now they're saying, well, how many tomatoes can we have for this new recipe? We don't know. So we can label that as X. So now all that matters is when we create our proportion, which we know is going to be 2 fractions that are equal to each other. We just need to be consistent. And what I mean by that is if I'm going to put tomatoes in my numerator, then I need to put tomatoes in my numerator in the other fraction. And if I'm going to put black beans here, I need to put black beans here as well. So you see I'm comparing both of these tomatoes to black beans. I could have reversed this, and I could have did black beans over tomatoes. But as long as if I did that, then my other ratio must also be black beans to tomatoes. So it's all about consistency. All right, so what I'm going to do now is just erase this. And I'm going to create a ratio from my original recipe of black beans to tomatoes. And that original recipe is then going to call for 1.5 cups of black beans for every 1 tomato. And then I have a new recipe. And a new recipe needs to follow the same way. So that means I'm going to do black beans over tomatoes. All right, I can't flip it because I'm not being consistent anymore. I'm not comparing them in the same way. Well, I know we have 6 cups of black beans, but tomatoes we don't know. All right, now, when we have a proportion and we want to figure out, okay, well, how many tomatoes do I need for 6 cups of black beans? Well, we create a proportion by setting the ratios equal to each other. And we know that they're proportional because we're not changing the flavor of this soup. Once we create that, I'm now going to write it up here so we can solve. So now we just solve it like we did in our last video and how we talked about this year, is we're going to use cross multiply. So we will do 1.5 times X is equal to 1 times 6. Now we have 1.5X is equal to 6. And then to solve for my X there, I divide each side by 1.5. And that means X is equal to 3. So that means that I need to have 3 tomatoes for this new recipe to have the same flavor. All right, so the first thing I would suggest that you do is create a table based off of what information we're given. And we know we're going to have two pieces of information here because to create a ratio, we're comparing two different things there. All right. And then we're looking to say, well, what are we now trying to think about? Well, we have the original recipe plus we have the new recipe. And that allows for us to then create a proportion. All right. There's going to be two other examples we're going to go through with this as well. All right. So now we're moving on to our next example. And the same thing, the directions are telling us to just write a proportion, but we're going to just practice solving these as well. So now in this one, we're saying a school requires 2 computers for every 5 students. So when they say 2 computers for every 5 students, they're giving me a ratio there. And our ratios are always simplified. So we're looking at this in a simplified ratio. Right? Now we're asked to write the proportion that gives a number C of computers needed for 145 students. So we're given a ratio that for every 5 students, we need 2 computers. Now we're saying, well, how many computers will we need if we have 145 students? All right, so the first thing we're going to do is draw that table. So I'm going to pause the screen so that way I can draw. All right, and now we're going to fill this in. So we have computers and we have students. And now, since they're giving me this ratio, we can label these columns any way we want. I'm just going to say the ratio is given to us, right? That's the ratio. And then the next one, we're looking at 145 students. I want to act like that's the whole school. So in this column here, I'm going to write school. All right, so now we're going to fill this in. The number of students or computers that we need is 2 for every 5 students for a ratio. So this ratio we know is 2 per 5 or 2 for 5. So that's our original ratio for 2 computers for every 5 students. We know how many students we have in this whole school. We have 145. We don't know how many computers we have. Well, they told us to use the variable C. All right, so now what we're going to do is we're going to use that ratio, and we can write it any way we want. I'm going to say computers over students. So that gives me a ratio of 2 over 5. Right? Then I'm going to look at it as our school. And I'm going to create the ratio as our school. Well, we don't know. Remember, it needs to go computers over students. Well, we don't know how many computers we need, so it's going to be C. How many students we have is 145. So these are the 2 ratios then that we can come up with based on the information of the problem. And then to solve these, well, since we know that they're proportional because it tells us write a proportion, and also if we're trying to then maintain that ratio of 2 over 5, we know it's going to be proportional. We just need to set them equal. So now we have 2 over 5 is equal to C over 145. And now we should be able to solve this. We will cross multiply and get 2 times 145 is equal to 5 times C. So I can then go ahead and write this. I'm going to write this up here. I can write this as 290 is equal to 5C. And then we divide each side by 5. And that then tells me that C is equal to 58. So that means that in order for us to maintain this same proportion, that we would have to have 58 computers for 145 students. And if we wanted to work this out or check our answer, we can go back to the 2 over 5 is equal to 58 over 145. And we can cross multiply to make sure it gives us 2 equal numbers. Or we could reduce this fraction and make sure it gives us 2 over 5 as our answer. All right, so there are ways for us to check our work for this. There are other ways for you to solve this as well. You do not have to use a table. But I think having this table is a good way for you to write out your information and a good way for you to stay organized. There's one more example we're going to go through. All right, same thing for this one. We are going to write and solve. They say a school has 950 students, and a ratio of female students to all students is 48 to 95. Write and solve, or this one does say solve, write and solve a proportion to find a number of female students, or number of students who are female. So I know what our ratio was originally on was female and all students. And then what we have is our original ratio. And then we have, what can we say for this? We can say total, right? Because they give us the total number of students that we have. Now I'm going to fill in the information I know. Well, the original ratio that they gave me, we have a ratio of 48 females for 95 when we have 95 all students, right? Then they told us that we have 950 students. Well, how many females do we have in the school then? All right, so the first thing we need to do is come up with our ratios. So we're going to look at our original ratio that they give us, and I'm going to do female to students because that's what they gave us, and that gives us a ratio of 48 to 95. Then I'm going to look at the ratio for our total. Well, we don't know how many females, same thing, we're going to do female to students. We don't know how many total females we have in the school. That's what we're actually trying to figure out. So we're going to represent that by F. Well, we have a total of 950 students in our school. So now we need to figure out, well, how many females do we have? And I'm going to show you a different way of solving this one because this one might jump out to you really easily. If you look at 950 and 95, we know that we can multiply 95 by 10 to get to the 950. Well, I could do the same thing for this numerator then. That in order for it to be proportional, we need to know that they need to change by the same rate. So I can simply just do 48 times 10, and that's going to give me 480 students, 80 female students. Right? And just to show you that this works is we're still going to cross multiply. So we will do 48 times 950 is equal to F times 95. Well, 48 times 950 is going to give me 45,600, and it'll be equal to 95F, and then we divide it by 95, and F is equal to 480. Right? So we could always use cross multiplying, but sometimes questions like this, we might be able to easily see, well, I can just multiply this by 10 to give me this number. So that means that we must follow the same thing when multiplying the numerator. All right, that is it for this video.